Hi, my name is Kumar Rajiv. I'm a software design engineer in Windows Driver Framework team in Microsoft. This democast is part of a series of democasts where I'll show you how to debug KMDF drivers using kernel debugger and familiarize you with KMDF debugger commands. KMDF provides a rich set of debugger commands using which you can not only explore everything about your driver but also about framework. In the previous part, I showed you how to load KMDF debugger extension, how to get help on commands, and how to dump KMDF log for your driver. In this part, I'll show you how to dump information about KMDF drivers such as list of KMDF drivers currently loaded, all WDF objects created by a particular driver, object hierarchy, and KMDF verifier information. Now, the command to dump all the KMDF drivers currently loaded is bang wdf ldr. The output of this command tells you what version of KMDF library is currently loaded. In this case, as you can see here, it's version 1.9. It also tells you all the drivers and their version of KMDF with which they were built. For example, in this case, OSR USBFX2 driver, it's a sample driver in WDK, and it was built using version 1.9 of KMDF. There are some drivers, for example, monitor driver. This was built using version 1.7 of KMDF. So this way you know what version of your KMDF your driver was built with. Now let's pick up one driver from this list and explore. The command that is really useful for starting this kind of investigation is bang wdf driver info. And this command takes driver name as argument, and you can get the driver name, as I said, from the list that I just showed you from the output of bang wdf ldr, or if you have a crash dump, then bang analyze will tell you the driver name. And if you are the owner of the driver, then you already know the driver name. So bang wdf driver info and the driver name without .sys extension. Let's pick up OSR USBFX2 driver. It takes some optional flags as well, but without flags, the output is a summary of all the device instances created by this driver. In this case, as you can see here, only one instance of WDF device was created, and this is for FDO. It also gives you current PNP and power states. For example, currently the device is in PNP started state. It also tells you any driver context set on the object. Also tells you if there are any callbacks set on this. If you need any help on any debugger command, you can use wdf help. This gives you a list of all the debugger commands and their uses. Now going back to bang wdf driver info, I just wanted to tell you wdf help is there. Now let's go back to wdf driver info and use some flags. Now there are two flags that are very useful, which I generally use. One is 1 and the other is FF. So you can use tab to autocomplete the driver name as well. It's a very useful feature, and it works on not only the modules but also the commands. Let's try 1. Now the output gives you a summary of verifier settings. In this case, the verifier is turned off for this driver, so it tells you that. And this is not the driver verifier, just to clarify. This is KMDF inbuilt verifier. And you can enable the verifier, KMDF verifier, using WDF verifier.exe tool, which is part of WDK, or starting from version 1.9 of KMDF. If your driver is built using 1.9 or higher, then when you enable driver verifier on the driver, it automatically enables KMDF verifier. The output also tells you, gives you a summary of count of all the objects created by this driver. For example, in this case, WDF-Q, there are 4 WDF-Q objects created by this driver, 1 WDF device, and similarly, there's one WDF USB device also, so you know that it's probably a driver for USB device. Now, the other flag that is very useful is FF. This gives you a complete list of all the objects created by the driver. Now, before I go into details, let me tell you something about object management in KMDF. As you may recall, KMDF provides an object-based interface to drivers, and drivers basically have access to handle to object and not the pointers to the object. And there is a parent-child relationship between objects that you can establish to control the lifetime of objects. Also, every object internally derives from a core object. So you will see the benefit of this one later on in dumping the objects, where you can use a generic command or a device type or an object type specific command. Now, this output tells you the hierarchy of the objects. For example, WDF device is child of WDF driver. WDF queue, this instance, is child of WDF device, and similarly other objects. Now, let's pick up one object from here and try dumping that. Now, before I dump that, as I told you before, there are 2 ways of dumping objects. One is generic command, bang WDF handle, and the other is object type specific command. For example, if the object is WDF device, then bang WDF device would be the command. Since all the objects are derived from a core object internally, you can use bang WDF handle on any object, whereas object type specific commands you can only use on the object type. So let's dump this WDF device using generic command as well as object type specific command. This is the generic command, bang WDF handle, and it tells you mostly about the core object from which this object is derived. For example, ref count is 1, and it also tells you context set on the object. It also tells you parent of this object and the type. It's WDF driver. It also tells you the owning device and the underlying object. And as you can see here, wherever you see a command suffix with bang symbol, then you know that it's probably a command, and then you could just do cut and paste and try dumping that. So in this case, this command dumps the underlying object, or gives you hint to dump the underlying object type. In this case, it tells you it's an FX device object type, and gives you the command line to dump the type. Now let's dump the object using the object type specific command. Since it was device, we use bang WDF device command. I picked up the wrong address. Let me pick up the right handle address. Here we go. So the output is a summary of information about this device instance. For example, it gives you all the WDM objects involved in the stack. This one is for this WDF device itself. This device object is for the one attached, and this is the PDO. It also gives you current PNP power and power policy state. Tells you about the default WDF IO target. It also gives you very useful information about if there are any pendant PNP power ERBs, and also whether the device stack is whether this device instance is the power policy owner for the stack. Now let's pick up one more object. So this command is very useful because this is most of the time this is the starting point for investigating further. For example, if you have a USB device driver and you want to investigate or get some more information about the device, then probably the starting point would be use this command bang WDF driver info and your driver name with flag FF and find out bang WDF USB device as we see here and dump that. So now it gives you information about the configuration descriptor and number of interfaces, number of pipes configured. It also gives you a hint on using other commands. For example, bang WDF USB interface. You can use this command to get more details about the interface. It gives you a hint on bang WDF USB device. You can use this command to go further into details of USB pipe. And you can use bang WDF help to get more information on these commands. Let me dump bang WDF USB device. No, USB pipe, sorry. So here you get more information about the pipe. And similarly, you can dump other handles from the list. Now, I'll tell you how to enable verifier to get verifier to basically get some more verification done on your driver. There's a tool called WDF verifier.exe. It's in WDK, and you can do a lot of things with this tool. For example, enable verification or increase the verbosity of KMDF log or increase the buffer size of KMDF log. On the left hand side you see all the KMDF drivers not loaded but present on the system, and also the ones that are loaded. You can choose one driver from here and you can select this checkbox, verify this driver, and this will enable KMDF verifier on this driver. This concludes this demo. Do look for other parts of the demo to learn more about how to debug KMDF drivers. Thank you.